Okay, so we're getting into chapter 4 already, which goes into various skills and concepts such as um, coming up with or determining inequalities. And I'll show you what I mean by an inequality. Suppose I have a graph. Suppose it's a parabola, okay, which you're quite familiar with. And suppose it's on an xy axis like this. It crosses the x-axis here and crosses the y-axis there. So cross the y-axis here, cross the x-axis here, has a vertex here. And it's clear visually that everything in this area here is below the x-axis and everything else is above the x-axis. So you could say everything in green is smaller, and you could either equal 0 or you don't have to equal 0, but you could say it's smaller than 0. And what you're saying is the y in that green area is smaller than equals to 0. So if you had a parabola, let's say this, plus 3 minus 3 squared, y is equal to figure out if what part of that is below 0, you would figure out the x-intercepts, because if it hits the x-intercept, it's hitting y, so you essentially have to factor it. To factor it, you'd have to expand it. You get x squared plus 6x plus 9 minus 3, which would be plus 6. Then you'd realize, okay, it doesn't have a pure factor. You'd have to use the quadratic function. But let's just say instead it came out, just for argument's sake, it came out to 7x. And you could factor that as x plus 1 and x plus 6. And let's see if I've got that right. That should be, oh, this should be a minus here. So let's see if I come up with something different. For it to be x minus 3, it means the vertex is at 3, 3. And the minus 3 means it's down below at minus 3, 3, minus 3, I should say. If I expand it, I get x squared minus 6x. Plus 9 minus that, which is 6. And again, that's still not factorable, but let's say I instead have it at 5, just to make it easier on me. And I would determine that the factors are indeed x plus 6 and x minus 1. Let's see if that works. No, x minus 6 and x plus 1. And right away my drawing's not correct, because it's an indication that this over here would cross the y or the x-axis at minus 1, 0, and it would cross the x-axis here at 6, 0. But I now realize that everything between minus 1 and 6x, my graph is below 0. So if somebody said, okay, where is it below 0? I would say from minus 1, smaller or equal to x, smaller or equal to 5. Now, obviously, this was kind of a botched example, but I'm just sort of showing you the logic that this chapter wants you to do. They want you to solve, essentially, two situations that are specific. Another thing that they want you to solve is when I have a black line like this, and I have another red line like this, they both clearly have a negative slope. But tell me, how many times will these lines cross? Only once. At that point, both their x's will equal, the red x will equal the black x, and the red y will equal the black y. Well, what's interesting about this, and that's the only point they will share the same x and y value, well, that means if I have a formula for one, let's say one of them is minus 2x plus 3, and I have another formula for another, let's say minus 4x plus 4, well, I've just determined they only meet where their y's are equal, and I've just determined what their y's are equal to in sense of a formula, so it means their x's, or if their y's are only equal at that point, it means I will only discover where they meet by making their formulas equal to each other. So that's an important skill to learn. So when I bring the minus 2x to this side, I get minus 2x total. When I bring the 3 to this side, I get plus 1. It's going to equal to 0, and actually just leave the 3 there. and bring the 4 over. So I get minus 2x is equal to minus 1. Therefore, x is equal to 1/2, which means they meet when x's are both here, 1/2. To figure out where they meet on y, I would then take this half x, put it in the here. Minus 2 times 1 over 2 is minus 1, plus 3 is 2. So they meet here, and ironically, not ironically, but interestingly, if I plug it into this formula, I'll get the same result. I'll get minus 4 times 1/2 is minus 2, plus 4 is 2. So it doesn't matter which formula I plug it into, I will discover the y. And now I have the x and the y where they meet. You're going to have to do this logic all sorts of times. And sometimes you're going to have to do word puzzles. For instance, there's a puzzle in this book that describes an arch. And all they tell you about the arch is that it's 192 meters tall, I think. I think they actually say it's 192 meters wide and 100, I don't know if it's 190, but there's an example in the book. And they say they're going to hang a flag at 150 height. So 150 height. They're going to just determine that there's a wire that says 150 height. And what they want to know is what are the coordinates essentially here on the top of the bridge. And you know it's 150 high, but you don't know the x values. You don't know how far in we'd have to hang it and how far in, or essentially they want to know how long that wire is, let's say. How long a wire do I need? And to do that, you need to know the x values and the distance between the x values. Well, you might say, well, they haven't given me enough information. Well, they told you it's 192 wide. So if you start at 0 here, and go all the way, you now have 0 to 192x. You also know it's 190 tall, and you know that the vertex of any parabola is halfway between their two x-intercepts. So you know the halfway point is going to be 86, which means at 86, 190, I now have the vertex. I can either use the vertex formula and then plug in any point I know, or I can use the factored formula. So for the factored formula, I would write it as y is equal to a mysterious a, and one of the factors is simply x, and one of the other factors is simply x minus 192. To solve it, I have to plug in any value of xy that I know that's not on the x-axis, and that's the 86, 190. So I plug in 190 for y, I leave a, I plug in 86 for x, and then I plug in 86 minus 192, which is minus 86 for y. And then, oh, yeah, I've got to just plug in, I've got to plug in the actual x value, sorry. So I've got to plug in 86 for x, and 86 for this x minus 182, not 192 is minus 86. And then I multiply them out, I get some crazy number, doesn't matter what it is, and it's going to be a negative. So I get this. As soon as I get it, there we go. 190 is equal to negative this a, which means a is equal to 190 divided by that. So a is equal to, what is a is equal to? You take this, I'm just going to divide it by 190 and then flip it. Where's the 1 over x button? It is right, should be right around here somewhere. There it is. So let's say 0.257. And it might have been even worse than that. Might have been 0.257. Yeah, 0.0257. So suddenly I have my formula. I can put this up here, and boom. And now you say, well, what good does that do me? Well, remember that you were going to hang the flag 150 meters up, which means you know that your y at that point is 150. You just need to now solve your x. When I expand it, I get 0.250 is equal to negative. That's got to be a negative, which makes sense because it's facing down, right? Negative 0.0257. When I expand this, I get x squared minus, let's see, minus 192x, and there's no y-intercept. Remember that this is squared. And then when I expand it, I get another number. So if I want to do that, I get 192 times 0.0257. And I get this nice number here. And when I get it on both sides, I get this. I now have an a, a b, and a c to put in the quadratic formula, and it will spit out my x roots. It'll essentially tell me the two x roots. Now let's say I get x roots, and I'm not going to bother here, but let's say I get an x root of 5 here, and I'll get the equivalent 5 less on here. I'll get 187. I now know an x value to an x value, and I know that this wire is now 182 meters long. It's the distance between 5 and 187. And that is how you would solve these things. But it's essentially looking for this point here. They might even say something like, if I want to put a full sign in here and cover it in paint or whatever, or if I want to hang it straight to the ground and cover it in paint, how much paint will I use? But you can see that you visually have to learn how to do these things, and that's what this chapter is trying to get you to do. And they run you through basic algebra, and I'm not going to do this basic algebra. You also have to learn to get rid of this 3 and this 4, and the secret is to multiply both sides by 12, and it will leave a 4 times this on this side, and it will leave a 3 times both these things on this side. The top part, 7 minus x. You also have to, they also want you to learn how to factor from the last chapter, cubics and quartics, and remember how to spot certain things that can factor out. For instance, both these things can remove a 3x out of it, and you're left with a cubic. This one's a difference of cubes, and this one they just want you to remember how to factor using synthetic division. Then they want you to sketch a graph, and fortunately here they give you all the x-intercepts, and here they give you the vertex. Figuring out the x-intercepts here, you'd have to set y to 0, expand, and solve using your knowledge of synthetic division from the chapter before. And then again, they want you to remember basic factoring. Here we have minus 2 minus 5 is the roots, so the x-intercepts are 5. The roots are 5 and 2. It'll actually, 5 and 2. Determine the roots of each of the following. You've got to isolate to one side. You got to factor out 2. You get x squared minus 9. So it's x plus 3 and x minus 3. So the roots are 3 and minus 3. And so you just got to, they just want you to remember how to factor. Then they want you to remember how to interpret a graph. So he's walking a bit faster in the second part because the slope is steeper. You can calculate the speeds by calculating the slope between those 2 points. Is she moving away from the motion sensor or towards? She's moving away because the distance is getting greater. Then a t-ball player, they're giving you a parabola. H is the height in meters, so the actual start at 0 seconds is 0.5 meters off the ground. How long is it in the air? When it hits 0. So in this case, you have to factor it. To factor this in this case, I would factor out the minus 5, possibly. Or I would use the quadratic function to figure out the roots. And one of the roots on the right will be when it hits the ground. The one on the left is irrelevant because it's negative time. Determine the average rate of change. So you have to remember how to do that. And estimate the instantaneous rate of change. So you have to use your h for that. So they're letting you bring back your skills. And another good point is you will find as you go that you'll forget chapter 1 and chapter 2. And it's important to review all your notes as you move through the chapters, because all of this stuff we're learning here is going to be used in calculus. Here's that arch. They want to see a horizontal cable from 175. Draw a sketch, determine the quadratic function that would model this. How do you determine the leading coefficient? Use your model to determine the length of cable. So we did all that. So then they give various problems. Here's a silo with a domed roof, and they ask you to develop a quadratic equation for it, for the volume. Well, half a sphere you'd have to look up. Here's the full sphere here, and then they take half of it here. And then they add it to the volume of the cylinder, which is the volume of the circle at the top of the cylinder times its height. Cylinders' volumes are very easy to memorize. Then you have to expand, and they say, well, we want this volume, which is 684 pi. Then you have to put it all on one side like this. Now you have an a, b, c in the quadratic function. They even factored out a common element to make it 45, 2, and minus 20, 52. Then they put in, let's see, what did they give us? What was the overall question? Determine possible values for the radius. So you have to essentially figure out the roots of that quadratic function. So you set it to 0. And they've rearranged it in terms of what's important. And they've tried to figure out, using synthetic division, using factor theorem, a possible root that will result in 0. And they determine 6 as one of them. That's because it's a cubic. Another way you could do it is the way I like. So let's say you have this, and 6 is hard to get to, right? It takes a lot of calculation. Personally, we found that synthetic division is faster. So let's say you have these numbers to work with. Okay, so you know you're working with a 2, a 45. We're missing the r value. There's no r value. And then we have minus 2052. So some of the calculation is going to be hard. It's a lot faster for me to use synthetic division over and over again to reach the right root. Now remember that the remainder will be 0 if I get the right one, and that you add each time. It's quite clear that we're not going to get anywhere near the right root on the first time. So 1's out. It's also quite clear that minus 1 would be out, because we're just not getting big enough. Not even close. So instead of doing all the minuses now, I'm just going to use a positive to see if a number kind of gets close. I'm going to use 2 now. We can almost instantly see that positives aren't going to work. So we should just focus on negatives. So I'm going to just focus on negative 2, 3, 4, and 5. And actually, no, I should focus on the positives, because the last number's negative. So we're going to just do 2. Close. So essentially what we're looking for is we need a number here. You can also do this. Now look, this is a good technique. We know that our final number has to be 2052. Let's work backwards using synthetic division. We know our final number has to be positive 2052, and we also know that the number before that got multiplied by 2 to get there. So the number before that had to be half of that. So we can use 1027. We also know it got added to 0 here. And to get to that 1027 on this line, it had to be half over here because it got multiplied by 2, right? So what we shouldn't do, we can easily figure out that 2's not going to work. What we need to do is, will it work? Let's see. Yeah, we don't know what we're dividing it by. So we don't know what A is. Let's call it A. Well, we do know it's going to be A times the 2052, or A times 2052 divided by A to get there, right? We do know. Will it work? I don't actually, backwards won't work. So we're just going to continue on with our process. Let's go with 3. 6, 18, 53, 63, 180, whatever. So we know 3 isn't even close enough. And I know it's positive. The root's positive because I know I'm dealing with a radius, right? So the root's going to be positive. 4, well, let's jump right to 5. 2, 10, 65, 325, something like that. Close, 15,075. No, it's even better than that. 15,000, 16,025. Close. So I know 5's close. 6, 2, 12, 6. Add those two, I get 57. 6 times 60 is 360 minus 18. You can figure out how I did that. Six times 2 is 12. 6 times 5 is 30 plus 1, 31. Now, I got it wrong somewhere. Because we know 6 is the right answer, right? Oops. So it just means I did a multiplication wrong. So this is going to be definitely be 12 here. 57. 6 times 7 is 42. 6 times 5 is 30. Plus 4. Add those 3, 42. 6 times 2 is 12. 6 times 4 is 24 plus the 1, 25. 6 times 3 is 18 plus the 1. Was it 18? No, plus the 2. 20,052. So I indeed get it with 6. And right away, we get that. But we know one of the factors is 6. So that's one possible root, which means we're left with a factor of x minus 6. And we're left with 2x squared plus 57 plus 342. Now the problem here, and the reason I don't have to continue on, is the only possible roots left over are x plus something and x plus something. That's the only way you can come up with a positive and positive. Since these are negative roots, negative something, let's call it negative a and negative b, those aren't possible dimensions, which means that's the only root possible, 6. So only one radius will work to achieve the volume they want. But they walk you through that quite nicely, as opposed to how I just did it. But they're using, you know, this would take a long time to come up with 0. I like the synthetic division trial and error to realize what number we got to get close to. And then we see they do the quadratic function here, and they discover that both these roots are negative and therefore can't be dimensions. The radius cannot be negative. So you got to use some logic. Then they run you through methods here of solving it. And the secret here is to find a factor that works for 1. Here they take all possible factors of 12 here, 4 and 3. And they actually do it as they take all possible factors of 3, and then they take all, they take 3 over 2, 3 over 2, 1 over 4, and 3 over 4. They're just taking them as fractions. But they start with 1, they discover nope. They start with minus 1, they discover no. And then they move on to 3, because that's the next possible factor of 3. And they discover, oh yeah, 3 works. Once they discover 3 works. They come up with the polynomial 4x squared minus 2, which is a difference of squares. So you get 2x plus 1 and 2x minus 1. And of course, that's what they come up with here. And they come up with the possible roots. Then they go back and verify that they got the right answer by plugging all these roots into the equation to make sure they get 0, which they do. So therefore, the possible roots they present here. Then they remind you that sometimes you can solve it by factor by grouping. So here we have a cubic that had commonalities. And here you're going to just notice the numbers, 4, 12, 1, and 3. And you're going to say there's a pattern there. They're all multiples of except for the x, 12. So you just want to check once and you discover, oh wait, I could have easily factored by grouping here. Then they give you real life scenarios, and they only care about this one from 0 to 8 seconds. And you discover that a cubic like this will look like this. And you will also discover that they only care about this part here. And that's the only part where the whale jumps above the x-axis, or which they are calling the water. So that means you have to determine where the x-intercepts are in between this obvious point. And it becomes obvious when you find all the x-intercepts, because you'll be able to see, oh yeah, that happens after 8 seconds, that happens before 0 seconds, so I'm only concerned about these two. That's why reading the question is really important. So they go ahead and they do that. They go through and they come up with a quadratic equation. And it says when are both these whales at the same height? And they both have, one has a cubic equation and one has a quartic equation. And when you make them equal to each other, so in my graph that I kind of got wrong about how I'm analyzing it, the other whale is going to be like this. And they want to know when the whales are the same height, or essentially when their equations meet each other, which means you make them equal to each other, and you put them all into one side, which is what they do. They make them equal to each other here, and they put it all on one side, and then you want to factor, because where they meet, they will share the same x and y value, which is why I went through before. And they discover, oh, 4 is a possible factor. And they're using the calculator to come up with it. So best thing to do is punch this into Desmos and just do f of 1, f of 2, f of 3, f of 4 until you get the 0, and then go back to synthetic division. So they find 4. They use synthetic division to come up with the next cubic. And then they keep going and they discover 9. And they go back and factor 9 out to come up with this quadratic, which is factorable into this, and then they come up with all the possible times when these whales are the same height. But now the secret is to make sure that happens between 0 and 8 seconds. Well, the first one is time at 4, the second one's at time at 9, and time at 1.5, but we only care about the first 8 seconds, so we only care about time 1.5 and 4, which is why they then conclude that these are the only valid times from 0 to 8 seconds. So you can see the two objects, once you make them equal and turn into one equation that equals 0, you're essentially raising the x-axis up to the level where they meet or are the same height. And you're saying, when does that happen? When are they going to be the same height? You can even draw it like that. But that's all that making two equations equal each other is you're essentially finding their new x-intercepts that are where they meet instead of on the x-axis. Then the book continues. The next example they give is they solve each of the following. So they're essentially just asking you to find the factors. So you just use your knowledge of synthetic division. And then they just come up with one solution because they want to see, what are they trying to see? Select a strategy to solve the polynomial that's not factorable. They determine the first one never crosses the x-axis. Then they determine the next one I'm not sure what the point of this is. The first one you can figure out that it never crosses the x-axis, so it has no factors. The second one crosses the x-axis because it's a cubic. And because it doesn't have an easy intercept, they essentially just graph it. I'm not sure what their point was there. Then they just want you to make sure you understand what you're doing. All the books will show you a method to solve each of these equations as you go along. So find the zeros. Okay, this is A. Heck, the roots are 0, 1, -2, and 2. That's because if I substitute any of those numbers in for x, the resulting y will equal 0. That's all zeros are. So B, the next one, it will be -3/2 for the first one, 5/4 for the next one, or -7. Now I've covered this in other chapters. 3 for the first one, -5 for the next one, and 4. D, you're essentially finding the x that will create any of these brackets, make any of these brackets 0. If one bracket is 0, it will multiply the others, so it doesn't matter what the others are. That's why 5/2 works in that regardless of what it becomes in the x plus 6, because the second bracket of 0 will nullify the first bracket. So in the second one, which is x squared minus 9, x can be 3 or x can be -3. That's because if I square both those, I'll get 9, and I subtract a 9, I get 0. And finally, f minus 5, and you've got to factor the next one. And it's clear that the next one is a number that adds to -4 and comes out to -12. So that's -6 and -2, which means the zeros are 6 and 2. Now if you grab your answer sheet, you'll see that they'll give them right there. And that's pretty much what they're doing. I forgot the -2 here. Essentially, it's any x that I plug in here that will make one of these brackets 0. And that's why this one's -2, and this one's 2, and this one's 1, and this one here is 0. Then they want you to solve each by factoring, and they want you to make sure you do it correctly. Okay, and then they want you to verify it using like your graphing calculator or Desmos. This is 3x squared, 3x cubed minus 27x is equal to 0. You always have to make it equal to 0 to solve it. Right now, you haven't been taught other techniques. Then we're going to notice that I can take 3x out of both of these. I'm left with x squared minus 9. So I'm obviously left with 3x, x plus 3, x minus 3, and boom. And if I take a graphing calculator, that's what I'll get. I'll get a graph that this is a cubic right here. So it's going to come down. It's going to go through -3, 0. It's going to go up. It's going to come through 0, 0. That's what this x represents. Then it's going to go down and come up through 3, 0. And since it's a cubic, it must continue on like that. So you're going to see something like that. And these hills are all pretty much going to be equally spaced because the distance between these values is 3, the same. Okay. And continue on. I'll just put this down for A, and I'll try to go in order. Essentially making you get your skills in order. So the only thing that happens here is I can make this whole thing equal to 0, like this. And when I put it on the left side like that, they both become minus. And it's going to be equal to 0. Right away, I notice I can factor out a 4. And I'm left with x to the 4 minus 6x squared minus... can I factor out a 4 from that? I don't know. 54. I can at least factor out a 2. Let's see if 108 is divided by 4. Yep, 27. My brain froze there. And that makes factoring it a lot easier, because now I get 4. I got to come up with something multiplies by 9 but adds up to minus 6, so minus 9. And x plus 3 is equal to 0. Sorry, this should have been 0 up here. 0. And there I can see all the possible roots. Oh, one thing, because this is a 4, this is actually x to the 4 minus x squared, and this is actually x squared and x squared. This one here won't have any roots because x squared can't be equal to minus 3, so that'll be above the line. And this part here can be x is equal to 3 or x is equal to minus 3. So if asked for the roots, these are the only two roots where this crosses the x-axis. So it's going to cross the x-axis line. Because it's cubic, it's going to come down, it's going to go through minus 3, it's going to come up through plus 3, then it's going to go up, and it's going to do something like that and go up. Let's check out Desmos and make sure. 4x squared minus 24. 4x squared, no, 4x to the 4 minus 24x squared. And plus 104 was it? No, it's minus 104. Oh, you have to zoom way out on this. So let's see if we can just make our y-axis 0 to 1,000. No, even 0 to 1,000 won't do it. Yeah, okay, actually the bends occurred down below. That makes sense, actually. So because that would be symmetrical around here. So that's what it actually looks like. Now, did they want us to graph? No, they just wanted to verify the answers. But sure enough, here, look at the x-intercepts. Ooh, did I get a number wrong? I might have got a number wrong. Minus 108. I got this number wrong. Okay, there we go. 3 and minus 3. Okay, let's continue on. Now this one, you have to do synthetic division unless there's a grouping pattern. So I can say 3, 5, yeah, I can see a pattern there. So if I take x out of all of them, I'm left with 3x squared, right? 3x cubed plus 5x squared minus 12x minus 20, correct? Is equal to 0. Let's see. 3, 5, if I took 2 out of this, I get 6x minus 10. If I get 4 out of this, I get 3x minus 5. Huh, interesting. Let's try taking, so on the first one, I can take x squared out of both of them. and I'm left with 3x plus 5, right? And the second one, I can take minus 4 out of both of them, and I'm left with 3x plus 5, which means for the second one, I successfully grouped by factoring instead of doing synthetic division. And you can verify it by expanding it, but you should find roots at 0, 0, 4, 0, and minus 5, 3, minus 5.3, 5 over 3, 0. Those will be your 3 roots. You can, again, plug it in if you want. 3x to the 4 plus 5x cubed minus 12x squared plus 20x, was it? Minus 20x. Oh. And sure enough, when I zoom in, that is negative 5 over 3. You take your calculator and confirm it. There's 0, 0, and there's 2, 0. Oh, except I got 4. How did I get 4? Okay, I got to go back and make sure because I got the wrong answers. Let's start again. When I take x, that's correct. When I take x out of this first one, I get 3x squared. No, I got to take x squared out of this one. That's what's going on. Ah, right there. Because I got to take x squared out of the first one. X squared. So I'm going to produce another one, I think. X squared is equal to 4, which I should have a minus 2 and a 2 right there. So that's 2, 0, and minus 2, 0. Let's see if I... There it is there. So let's zoom in on this. There's the negative 5 over 3, and there's the negative 2. So that's a small technical error, and that's because I failed to see that I was taking x squared out of both of them, not x. And x squared minus 4 produces 2 roots, minus 2 and plus 2. So there we go. Technically, I had the right idea anyway. Whoa. You would discover that I make a lot of arithmetic errors, but my point in these videos is to show you the technique. And generally speaking, the technique I'm using is correct. This one's going to be a bit of a problem, but I can take an x out of it. And I can take a 5x, no, 2x, 2x. And I'm left with 5x squared plus 13x minus 6 is equal to 0. Just remember that's x squared. So I'm looking for a number that multiplies out to minus 30 and adds up to 13. I can immediately see it's, let me make sure I get that right, 5 plus, oh, and adds up to plus 30, plus 13, so I'm dealing with plus, interesting, plus 6 plus 5 doesn't work. So minus 3 plus 10 should normally be good, but it doesn't work. It would work if this was positive. So I'm looking more for something, well, what are the possible factors of 30? 30 and 1, 15 and 2. There we go. Duh. So we know it's minus 15, sorry, plus 15 and minus 2 because these add up to 13 and make that. Using the slip and slide method, I get x plus 15 and x minus 2. That was terrible. Just put it up. Just get rid of this now. And x minus 2. And when I divide them both by leading coefficient of 5, I get 3 here. And it can't divide here, so it goes 5x minus 2, which means these are the factors. If you expand it, you will get what you started with, and you can even graph it if you want. I'm not going to go to the graphic calculator on this, but it goes through 0, 0, minus 3, 0, 2 over 5, 0. It is a cubic. This is the most left point here. So it comes up and goes through minus 3, 0. It doesn't have a y-intercept, so it goes through 0, 0. It comes back down and goes quite quickly, comes back down and quickly turns around and goes through 2/5, which is less than 1. So it's just going to be a little blip here and shooting off like that. This little blip will barely be noticeable, and you'd have to zoom in on it. Okay, let's continue. So all these are factorable without synthetic division. This one you have to say, those can both be divided by 2. Left with x cubed plus 81. And we just did differences of cubes, which means I'm left with x plus 9 and x squared minus 81 minus 9x plus 81. And I can't factor the second one anymore. If it has roots, you could use, it will have roots. You just take a quadratic calculator. Wherever, and you just put in those ABC roots here if you wanted to graph it. So I got 1 minus 9 and 81. And you hit calculate, and it gives me 2 possible roots. And it's saying no, it's not possible. It's doing imaginary numbers. So it's saying there are no roots for that. Yeah, because as soon as you see an I here, it means they had to square root a negative number. So that means the only roots for this are minus 9, 0. Even though it's a cubic, it will just go through here, minus 9. It'll probably squiggle up here and go up, or it'll squiggle down here and go up. I'm curious, so I'm going to put it in there. 2x cubed plus 182. $162. Okay, the squiggle happens down here. Oh, I should have noticed also that they gave us the y-intercept, so that would help me graph it. And you can see it just kind of does a double slide there. Right. We will learn how to graph these more accurately as we go. Oh, I didn't get the right root though. So let me see what I did wrong there. I got a 2x cubed plus 182. Okay, so I did a factoring wrong. Oh, I know what I did wrong. No, I didn't. There's no cube root to 81, but there is, my bad, 4.32. So you could technically do it like this. So this part, it's not, I didn't do it right. So it would be x plus the cube root of 81, which doesn't exist. However, you could break it down as in 9 times 9. Nope, still doesn't work. And then over here, it would be x squared plus the cube root, and that would be a minus actually, minus Let me do it properly here. Why did I put x plus the cube root of 81? Because there's no cube root of 81. That was my mistake. However, I can still technically use the cube rule to come up with all the factors. And then I just got to do 81 like this. So if I'm going to do it like fractions, and I also have to remember that this is not a plus, it's a minus. If I'm going to do it like fractions, it would be 81 to the third. 81 to the third times x. This is x squared. And this last one would be the square of the cube root, like that. Now, I don't know if that's going to be in the book like that. Be great if it is. But that's the actual cube root, which means for this to be 0 here, x has to be equal to the negative cube root of 81. The cube root of 81 is this. So at minus 4.32, we should find what we're looking for. There it is. That's my bad. But notice I could still come up with it by understanding the cube root formula. I'm more curious what the book says as an answer. So we're right over here, I think. What number are we on? Oh, we're right over here. Oh, they just wanted the roots. We're on 2. So it's this one here. Oh, they just want the answers. Okay, they just want the roots. So yeah, sure enough, those are the roots. Sure enough, those are the roots. Sure enough, those are the roots. Looks like I might have made a mistake for this one. I think I forgot that, oh yeah, that this is squared. This is squared. And then, sure enough, those are the roots here. There, look at that. They've simplified it a bit. They've turned 81 into 27 times 3. And they were able to take the cube root of 27, which is 3, times root. And remember, it was negative. This is the same as that, is the same as that, cube root of 81. They've just simplified it. They've kept it as a square root because that's way more accurate. So far, so good. But I can see now they wanted the roots. This you can instantly see when it goes on the left side. It becomes this. You can also see that I can factor out at 2x squared. And I'm left with this. X squared minus 24 is equal to 0. Then you can see that this can be factored out as it's not a difference of squares necessarily. However, it is in a way. It's x plus the square root of 24 and x minus the square root of 24 is equal to 0. And you just have to remember to keep the 2x squared in the front. Which means, and you have to remember to do it like this. Now you might say, okay, that doesn't have a square root except that 4 times 6. And now I can bring the 2 out. So this can be rewritten as 2 times the square root of 6. And so can this. That's the same as 24. Which means the roots will be 0, minus 2 square root of 6. I'm just going to write it like this. And plus 2 square root of 6, comma 0, comma 0, and 0, comma 0. And if I'm just writing the roots, it's just like that, which I believe I am. And then again, if I take the answer, there it is there. They've just written it as plus and minus 2 times the square root of 6. So those are solvable, and they just want you to stretch your mind. Now I'm going to have to stop. I know we're only on to question 2, but I have to stop.